Hi everyone. I told myself yesterday that it would be a small audience, but it's not. So I am not nervous, you are. My name is Remy Simons. I'm from ilionx. I am 34 years old. Still a youngster, as I consider myself. I'm a very big fan of everything that has to do with open source engineering, and since 2.5 years, we've been working on a platform at ilionx to serve Kubernetes to multi-tenants, to customers. And today I'm going to talk to you a little bit about how we experienced the journey in securing our network stack. I also like football. I don't know if there are any Ajax or Feyenoord fans in here. I am not. So we started our platform concept in 2020, which is 2.5 years ago, give and take. And we initially built it for only hosting our own platform tools. And then you have to think about stuff for supporting our SOC SIEM platform. You have to think about reporting dashboards, but also using stuff like Grafana, Prometheus, the Harvester for security, and a lot of other stuff, open source initiatives. Because we had like a server park, a lot of stuff in Azure, which was costing a lot of money, so we decided to migrate a lot of this stuff to Kubernetes. I will show you a little bit about the growth path in a second, just to get a context on how we started on securing our networking stack and why it's important. But the first customer came like, give and take, 1.5 years ago, and then it went really quick. Where right now we're running about 147 deployments. Actually, since a few days, it's been growing a little bit already. So as you can see, we started very small. What I'm going to tell you today is the small intro, of course. We're going to talk a little bit about what we do on network security. I'm not going to do an eBPF deep dive. Not as good as Raymond in the talk before, but we are going to tell you what we do with it on our platform, and we're going to talk a little bit about the layer 3 and layer 7 security that we do for our customers and for ourselves, of course. So we started in 2020, which was really basic, a very small team consisting of 2 to 3 people, where we used Azure network security groups and external load balancers, but we found out it was quite hard to manage, quite hard to keep in check. We had to do a lot of manual work. We had to do a lot of work in getting every customer the separate tunnel, separate network traffic tunnel, as you can call it. And it was very hard to automate. So we were talking about it, thinking about saying like, hey, we want to do multi-tenancy, but how are we going to do a proper multi-tenancy, especially on a security on a network level? I don't know if you have ever explained Kubernetes and especially the network and security context to somebody with not a lot of knowledge of Kubernetes. That's quite a challenge. So in 2021, we decided that Docker wasn't fitting anymore. We started using APIs on Kubernetes to automate a lot of this stuff. We used Flannel and Calico at the start, but back then, talking about 2021, start of 2021, Flannel and Calico wasn't a good fit. We troubleshoot for a week on an issue that apparently happened because Azure didn't support Calico features completely yet. So we decided to move away, and we decided to move towards Cilium, which we'll talk about it in a moment. We did, however, move to a private layer 7 appliance. And as of 2022, halfway 2022, we grew to 10 Azure hosts, which is 11, and well, you can see how much changes on a week. And we do all the deployment and initial config using Ansible. That's also including some of the network policies, where we use Cilium to safeguard our customers, to safeguard our own management tooling, and to safeguard all the tooling that serves purposes for our own stack, so for our own SOC SIEM solution. If you look at the growth within a year, going from give and take 3 customers to 14 is quite fast, especially if you consider that our team hasn't been growing that much. So we're still like 3 to 4 people. So I figured out this morning that I don't really have to explain Kubernetes pictures in this case. But we use a layer 3 appliance on top with a load balancer in front, and starting from there we go to a layer 7 appliance. That was when we started using Cilium, so we didn't think about all the network security stuff that much yet. But we did have a high level of security on our layer 3 and our layer 7, thinking about a lot of stuff needs to be done to security applications for our customers. A lot of stuff in this picture, well, a lot, that's overreacting. Some things in this picture will change, and I'll show you a little bit further on what changed exactly. So we only serve government applications and CMS. We also have some microservice stacks, so we have 2 customers at the moment that deploy a lot of APIs. Think about a restaurant application example. And there's a lot of stuff that it's on the slide that I already discussed. For example, we also eat our own dog food, so we use SOC solutions running on our Kubernetes platform, which is a very tricky thing at the same time, because it's also a sandbox environment, but it's also handling customer data. There's also security data flowing through it, so you don't want these deployments, these applications to be compromised. In the meanwhile, we're trying to use Cilium to serve secure connections, to also secure the tenants for every customer, while trying to maintain our own standards. And that's a difficult thing. Because you look at the problems that we faced when we were deciding that, hey, we have to do something with the very static stack that we have right now. We need to make it more dynamic. There were 3 issues that arise, like 3 main issues that arise. The first one is that we were using the layer 3 and layer 7 private appliance. Figured out that the API of these private appliances was not very automated friendly. We can log into the UI, we can configure a lot of stuff for the customers, but it's just not cutting it in the phase where we are right now. We're growing, more customers come every week, every month. So yeah, we need something that we can use to automate our network security. Secondly, as I just mentioned already, customers are asking more and more self-service. Just in the good context, the customers right now only use deployment files and storage and everything that comes with it. They deploy it themselves. If it comes to network security, we had a lot of discussions. People were like, well, I can just enable everything, right? Like, it's my application. I just open it up and then it works fine. We're still helping them and telling them, well, it's not good to open everything. Let's only look at the stuff that you really need. That's difficult. And at the same time, we're having a high security standard, but having a high standard means also that you need to invest a lot of time. That's something that we sometimes not have a lot of. And especially if you look at the current standard, so we had a lot of security tests already on our platform. We're running government applications on the platform at the moment. And it's very difficult to migrate to a new solution with new layer 3 and new layer 7 possibilities, and meanwhile trying to keep the same standard. Right? How are we going to make sure that the applications of the customers are safe and not compromising anything that we do on layer 3 or layer 7 level at the moment? And how do we teach the customer this? Because if they want self-service, they also need to understand what they're doing. Now, this is a big list. I tried to delay the amount of text on a sheet as long as possible, but I had to believe it on this one. So if you look at the security that we do at the moment, layer 3 security, some things to pick out that we can easily fix with the current network engine. It's the firewall, so layer 3 security, IPv4, IPv6, the routing and the inspection of every traffic, part of traffic that flows through our cluster. But if you look at the layer 7 part, there's some stuff that is possible with our current network engine, but there's also some stuff that's not there yet. So what we are doing right now, and that's what I'm going to show you in the talk later on, is that there's a lot of stuff that we're still working on. There's also some stuff that we already did. For example, securing the methods that people can use to talk to the API of their customer. And as you see this list, it's quite big. And last but not least, if we talk about the management part for Kubernetes, people that at their own company before have been busy with setting up Kubernetes clusters, but also look at which ports do I need to open, what connectivity do I need, how does VXLAN work, what do I need and other stuff. It's quite difficult. So that's one of the things that we were looking for. Wanted to minimize the attack surface on our management part. So basically the question is, how do we approach a handmade, like a very custom-made static environment into an environment where we can do network security on layer 3 and layer 7 level more dynamic. So we're going to put it in code, make sure that the customers can also deploy it themselves, make sure that we can deploy it ourselves, we can use CI/CD pipelines to do security on our cluster using Cilium. One of the most important 3 topics if it comes to the migration and design challenges As the first one that I think, it's actually a quote from a former colleague of mine, and I thought it was very interesting. We started the platform with doing all the security, right? So a lot of checkboxes, and we're doing every checkbox, and then, oh, we haven't had one checkbox, so let's not go live yet. And now we are looking into Cilium and actually thinking for ourselves, but what do we actually need? Do we still need to do all the layer 7 stuff that we want to do, or can we just only handpick a few of them and use these? The customers, of course, should be still able to do self-service, and we have to define a standard. So we have to tell the customers, like, you can do this, but you can't, for example, open up port 22 or something else. Just a basic example. So we use Cilium. Who of you people is using Cilium at the moment? Ah, that's good. That's a decent group already. Very big fan. What does Cilium do for us? We use it as a CNI, a high-performance CNI. We actually noticed that the moment when we moved from Calico to Cilium, the improvement for the application of a customer, the first customer where we migrated on, was actually quite a big difference. We use it to secure a cluster, and not only your cluster, but we also use it to secure the tenants from our customers. And using Cilium and using Hubble UI, we can also investigate the layer 3 and layer 4 network flows that are flowing through our cluster. It's very easy and very good to know that, hey, if a customer is doing a call and he's mentioning that he can't reach the application, we're using Hubble and Hubble UI to identify the network flow that is going through and make sure that we can fix it. See the source address, see the port is using, maybe it's doing something wrong, and we can use this to analyze and troubleshoot it a bit more. As I said, I'm not going to deep dive into eBPF, but why is eBPF and Cilium built on eBPF such an advantage for us? In a summary, we can see the events that are coming in more quickly, more faster through the Linux kernel, which is not getting adjusted a lot because it's a very stable product. And Cilium takes the data from eBPF, from the Linux kernel, an example, TCP IP source traffic, and we use this information to build the network security rules on. So in a Linux context, in a Kubernetes context, this is a basic overview. We're not doing all the topics ahead yet. So the stuff that we are doing right now is mainly the networking policies and stuff, is maybe doing the load balancing and the services, like connecting customer applications towards our cluster and towards the outside world. And we're doing the flow and policy logging. So we actually ingest it into our SOC SIEM, into our data lake, and we use that information to verify what is happening. Which is very important, because in case of a breach or in case of network security issues, we can use this data to analyze it even further. Now, the more important thing for us, besides being safe ourselves, is how do we approach the customers on this? What are we doing for the customers to make sure that their tenants, their applications, and everything related to is safe? I'm taking a step back, so we just showed you the previous setup, which looks really cool, but it's just, Kubernetes cluster setup, using Istio and using our layer 3 and layer 7 appliance. And we wanted to change that. We wanted to remove some components in order to make it more flexible. So what we did is we went to a new setup, which we built right now, and we're still improving. And you can see the little gray icons, which are the network policies that we did on a very basic level at the moment. There are a few more, but if I post another 6 gray pictures on this one, it's not going to be very viable anymore. But as you can see, we did some network policies on the kube system level. We did some network policies on our layer 7 appliance. And mind you, in the future, which is in about 3 to 4 months, we're already testing right now, we're also going to replace the layer 7 appliance. So we're going to do TLS checking, we're going to do stuff with certificates inspections, only allowing specific ciphers, and just calling out some examples. But what is more important is that we're also securing the network traffic between customer namespaces. To give you an example, the very first pen test that we had in 2021, there was a guy mentioning that, hey, I have access to the container of this customer, but I can just reach other containers. That's not good. I said, no, it's not. So we started to gridline the customer namespaces by only allowing specific traffic into the customer namespace and only for from a specific source, which is the stuff I'm going to show you. But this is very important because there's one big thing that you don't want is that if you're serving a multi-tenant Kubernetes cluster, you don't want customer A hopping to customer B and back and forth. Unless they're helping, but let's assume they're not. So setting the boundaries on this level means that inside the namespace, it's fine. Right? There's a front end, there's a back end within the namespace, maybe even a database. That traffic we allow, but we still do that based on layer 3 and layer 7. So we still look at API calls and methods that are being used. And we only whitelist specific traffic to and from services. The only ones that we allow right now is kubedns. And it's the traffic towards some central services that we host on a Kubernetes cluster. And then you have to think about stuff like MongoDB, Redis caches, Postgres. That's some stuff that we also host on our cluster. If it comes to egress traffic from the namespaces, I don't mind traffic going to the world. And some people will say like, well, you're going to whitelist everything outside. That's weird. But for us, at the moment, with the customers that we have, we never experienced any bad issues with traffic going outside. It was more inside the cluster and traffic coming in. So I'm fine with the world traffic. And only the Kubernetes supported traffic, so I already mentioned kubedns and the specific services. And we deny everything else. There's a function within Cilium, it's called policy audit mode. I don't know if somebody ever used it before. We deployed Cilium as a test purpose for the Kubernetes management systems. And we thought it was fun to not enable the audit mode, which wasn't fun, which broke everything. But if you use the audit mode, you can see all the traffic flowing through without Cilium actually doing a lot of stuff yet. So you can use it to fine-tune your traffic. And at the end of the ride, I want my customers to have templated policies. I want them to understand why we're doing network security properly. They can only do it within their own namespace. So everything outside of their namespace, something that we take care of within our automation, but everything inside the namespace is their responsibility at the end of the ride. And we help them with that stuff, of course. So setting the boundaries. On the left side, you see the policies before. I just take some simple examples to show you. And on the right side, you see everything that we changed so far. Just to clarify one thing, on the left side before you see that from entities is world, remote node, and host. To clarify this, Cilium can do traffic routing or traffic firewalling, however you want to call it, based on entities. So it's related to a specific IP or specific application or service within the cluster. These are reserved names. If you look at our picture from before, this is the picture related to the left policy, right? So we already did layer 3 firewalling, and we already did layer 7 firewalling. So for us, at that moment in time, it wasn't important to start whitelisting on CIDR IPs or a customer VPN or whatever, because we already did it. But since we want to get rid of the layer 3 appliances in this picture, what we have been building so far, we want to use the comparison on the right side for number 1 is where we only whitelisting the customer IP. And this is, in this scenario, it's related to a backend application, only for 443 and 80, which in this policy actually means that traffic from our ingress instance, as you can see in point 2 on the right side, traffic from the host or traffic from the remote node is the only traffic that is allowed, and the traffic from a customer IP, in this case a VPN, and everything else, and Datadog in this case, because it listens on some stuff as well. But everything else, all the other traffic in this case is blocked. This works, but there's some other stuff that you need to take care of. It's not only the ingress traffic, it's also the egress traffic. And mind again, this is all in YAML, so it's very easy to put this in your pipeline and to deploy it to your cluster. If you see it on the left side, we minimize the amount of namespaces that we used. And not only that, but we also added the services namespace that we used recently for Postgres data on port 5432. So in this scenario, if you look at this namespace for this specific customer, they're only allowed to go to the Postgres or to the namespace called CS, to an application called Postgres on port 5432 TCP. That's it. And kubedns. Everything else we just block. And this is also to prevent that on the ingress policies, we don't specify other customer namespaces. So for example, if this is the namespace policy of customer A, I'm not specifying customer B, and in Istio terms, in this case, it means that customer B can't access the namespace, looking at the ingress policy for this customer. And even though if we would specify the namespace over here, even though if we didn't mention customer B in the namespace for customer A, it would still not be possible, because I can mention it in the egress policy, but at the end, a deny is the one that matters. So it's not going to be allowed. So there's a few things that we want to improve still. And I didn't know this until 2 months ago, so that's kind of funny, since we're doing with Cilium, so much stuff with Cilium. Apparently, you can also whitelist traffic from a specific service account. At first, I thought it was like, oh, that's weird. Like normally, I would select the namespace as customer A, application is front end, and that's the traffic that I'm whitelisting. But what if I am a customer that has 10, 12, 15, 14 applications running within a certain namespace? It's way easier to use a solution to whitelist all the traffic from those applications to a specific service. In this case, we decided that everything that is running, and this is the Datadog example again, but everything that is running under the service account of Datadog in the Datadog namespace is allowed to go to the namespace of customer 1. Let's use a different example. If it's customer 1 production on the top, and if it's customer 1 development on the bottom, as in towards the namespace, egress traffic, you can allow the traffic from all the production instances to go to the development instance, if you would want that. It's a bad example, terrible example, actually. But just to show a different one than this one. Another thing is the sitter set that we use. So it's not only possible to use a specific sitter, it's also used to list multiple sitters. So, for example, if you're a team that has multiple VPNs or multiple locations that you want to whitelist, you can provide multiple sitter sets. In this case, we use a sitter set where we define the sitter of a load balancer and allow that traffic to go to 443 and only on the get method on / nothing else, so on the root. You can specify this even better with Cilium and these policies to specify multiple methods, or for this customer, an example, only allow backend access to use a get and a post on the /API backend. Meaning for this application as it's standing right here, that if you do, for example, a put or a delete on the /API, it will be denied by Cilium. Cilium will not allow you to do that traffic to coming through. Which is a huge improvement for us. And again, I just showed the list for layer 7 security before. So this is only a very small, minor part of stuff that we can do with layer 7. For Cilium, particularly, there's a lot of stuff that is still in development if it comes to layer 7 protection. It's really good, and we're trying to import most of it at the moment. Now, how do you manage, how do you visualize, or how do you see what is going on? At first, when we started with Cilium, when we tried to find out which traffic was blocked, which traffic wasn't blocked, we struggled a little bit because we used Hubble, but only Hubble is not always the perfect solution. So we asked ourselves, how can we do this even better? How can we see and use the data from Cilium to trace the effect of a policy? There's 3 options. One of them I already mentioned, which is Hubble Observe and Hubble UI. It's perfect, it works really good. But if you look at Cilium Monitor, or even better, Cilium Policy Trace ID, you can specifically filter out traffic from a specific policy. Why is this important? We have a governmental customer that has, I believe it's like 150 flows a second. So to be like, hey, there's a policy going wrong, they have 6 policies. So let's just do a Cilium Monitor and we will find that one single rule within the 150 requests a second that helps us. This works even better. So if it's about an ingress policy only for 80 and 443, or for the backend API, or whatever you want to pick, we can use Cilium Policy Trace and then the ID of that specific policy and only see the traffic that is matching that specific policy. Okay, so you don't have to look through all the big bag of logs anymore. And if you really want to use Hubble, who of you has used Hubble before? That's good. A little less people than using Cilium, so Might be a sign. No, I'm joking. So what you can see right here is that you can see the application that is being sourced, destination, and all the ports that are being used as a traffic destination. This is just an example. It's not our picture. It's just a basic picture of Hubble, which is even better that if you click on one of the rules, if you click on one of the parts of the traffic, Hubble will also tell you, hey, this is coming from this source IP with these headers. It's an acknowledgement or a drop. It's related to a specific entity, maybe even within a Kubernetes cluster. So it tells you quite a lot. One thing to remark, and I'm trying not to make this part a sales pitch. You also have Hubble Open Source and you have Hubble Enterprise. If you have Hubble Enterprise, you can also create network policies based on what you see over here. So if you run it in audit mode and you're not specifically sure in what traffic you want to whitelist, you can go through the customer traffic, you can click on the rule, and you can ask Hubble to create a network policy for you based on the traffic that you just investigated, which is very easy. But again, it's also better to learn making the network policies by writing them yourself. This is again another picture that I didn't have to show. But if we look at the management, so we talked a lot about customers, but it's also important for us as a team that we, so right now we have a layer 3 appliance protecting our 6443 traffic. So if I do kubectl get pods on our office, it works perfectly fine, but it does so because our layer 3 appliance only allows traffic from our own VPN. But I want to gridline that a little bit. Like if I'm going to remove layer 3 appliances, I need to make sure that even the management that we do on our cluster is also being used or being monitored by Cilium. There's two things really important. Is the policy enforcement mode is an always, that means that it always applies to policies. But if you use policy audit mode on true first, when you start gridlining your cluster, you can still test and audit stuff. Now, why do you want to put this on true first? It's actually very simple. We put it on false at the start, and at some point I couldn't reach the cluster anymore because we didn't specify the 6443 properly. etcd was broken. We're getting a lot of messages, panic, a lot of sweat. And that is the thing when we decided, hey, we can use policy audit mode and put it on true first, so we don't break our cluster immediately, because it was a complete brick at the first part. Mind you, we did this on the development cluster first, not on the production, because that would be a lot of trouble. But you can imagine that doing this on a production cluster for us is difficult, because there's a lot of traffic going on. You need to know exactly what you're doing before you turn policy audit mode off. Otherwise, your production cluster might just die on the spot. So it's a funny slide, because when we were making the presentation for KCD, we had a table here with all the ports and all the traffic from Kubernetes. So it's a terrible idea, because it doesn't tell you anything and tells you too much at the same time. So we decided to make a picture with the 4 most important flows that we noticed so far. So on the top, we still have the same policy. So we only allow management traffic from our VPN. And we only limit those to automating and admin functionality. So read out etcd if necessary, but also talk to the Kube API for management purposes. We whitelist that traffic based on CIDR and on remote node, which is on port 6443 and 10250. And if you look at the second one, it's the etcd peering that we whitelisted. This is only master 1, master 2, and node 1. We have a lot more masters and nodes than visualized here, but it would make the slide a lot easier. For the administration and for the Cilium VXLAN, which is number 3 and number 4, we still had to work with the entities again. We had to specify remote nodes, and remote nodes in Cilium terms means that's only the nodes in the cluster on the different ones. So if you're on node 1, it's allowing traffic from node 2 or from master 1 or from master 2. Why do I think working with the entities in this case is great? All right. So if we look at the network policy for a second, not this one, this one. Using these entities for us is a lot easier, because we don't have to specify a whole list of IP addresses from our master, to specify a whole list of IP addresses from our nodes. We can just tell Cilium that if it's labeled as a remote node, if it's labeled as a host within the Kubernetes cluster, you can just whitelist it. Don't have to memorize all the IP addresses anymore. And it does that with everything in Cilium in the network policies as well. You can route traffic based on labeling, based on annotation, well, labeling, not annotations. So what did we learn today? Maybe there's some people that are saying, like, Remy already knew this. What are you telling? I taught you a little bit about how we secure our customer namespaces on the layer 3 level by setting boundaries on namespace level, but also setting boundaries on the Kubernetes management level to make sure that customers don't actually brick anything. We also talked about how we handled egress traffic and limiting to other services, for example, the Postgres traffic that we do within our cluster. We talked about how to limit calls on specific endpoints, including the methods. Take a get, post, put whatever to /API, but you can name any sort of endpoint that you want over there. We talked a little bit on how you can monitor these flows and how you can troubleshoot them with Cilium if necessary. How can I identify network traffic flowing through our cluster, going through the kernel, and identify it and make a network policy based on it. We also talked at the end a little bit on how we use Cilium to secure our own cluster and our own management tooling. Because the last thing you want is somebody helping you on port 6443. That's really no joke. So that was my talk. So thank you.
Thank you.